So I took out a 4, right? So what do I have? 1 over e, 3 over e squared. Oops, 1. I mean, I could I could keep going crazy with this. It's not a bad idea to keep going. Just trying to get it to look as pretty as I can. It looks like I have an LCD of e cubed, right? So I'm going to have a 1 plus 3e plus e squared plus e cubed. And that's where I'm going to stop. Well, I could go one more step, right? Just trying to get some kind of final place. We did a lot of that in Calc 1, right? We had to rewrite answers. So now let me just double check my decimal here, right? What do I have? 4 divided by 3e to the 4th. And I forget already. 1 plus 3e plus e squared plus e cubed. Pretty damn close, huh? So 0.89, I guess, if I'm going 2 places. 0.91 is what is that what we got before? 0.91? Yeah. So pretty damn close, right? So like the WebAssign will ask you, and the book's a little bit unfair. It's asking a lot of times for 10 rectangles. It just takes a little bit of extra time. I'll always ask for 4, just to keep it as simple as I can. No, you want the first part of that on a picture?
Oh, no.
You okay? Okay. So, yes, not too bad. You're going to have the formula, all the midpoint, the trapezoids, Simpson's rule, all on your formula sheet, right? All of your derivatives on your formula sheet, right? Anything you're worried about on your formula sheet. So that's I think that's enough of a recap. Do you need anything else from last class? Sure. Well, that's where this error piece comes in. If you take a look at the error for Simpson's rule, yeah. So right here it says it says take the absolute value of the 4th derivative of I'm sorry. Here it is. the error bound for Simpson's rule is at most k times b minus a quantity to the fifth over a 180 n to the fourth, where n is your number of rectangles. And the interesting thing is, what is k? So I'm just reading this Simpson's rule error bound here. The interesting thing is, k is the integer that is the upper bound for the fourth derivative. Now, in this particular problem, it's hideous to deal with it. So, pretty much why I don't. I'd rather you have to do integration by parts than have to do just a direct integration. So I'd look for the fourth derivative, 1, 2, 3, 4, of that function, and then find the integer, the very first integer that's higher than the highest point of that function. It's just a mess to think about the fourth derivative of that particular function. What did I get? What did I get for f of x was x e to the minus x, right? And then my first derivative, I got negative e to the, right? I mean, horrible, right? What was it? I forget. Doesn't matter. So that will tell me how close I am, okay? But I'm not doing that with the class this semester. And if I did, I would use technology to do it. But I can't give you some problem like this because the derivative is so nasty. By the time you get the fourth derivative, it's incredibly nasty. And then you're just going to graph it anyway. Can I just do that? Let me see if I can do that. Let me see if I can do y equals d dx. Can I do d dx? No, it won't let me do an operator. Oh, yeah. So I'm going to do another d dx. Oops. Why is it doing that? I just want to see if it will let me do a fourth derivative like this. Well, let's see if it lets me do the third derivative. Yes, it does. So one more derivative out here. So look at the from 0 to 4, you can see the low point is -4. So I'd need an upper bound of 4 for my error. I don't know why I'm doing this because I don't really want to, but it's okay. So my error for Simpson's rule, I got a 4 for my k. I need 4 minus 0 to the fifth over 180 times 4 to the, because n was 4 for me, to the fourth. So it's 4 to the sixth times 180 times 4 to the fourth. So it's 16 over 180. Eight over 90, 4 over 45. 4/45. Yeah, point oh eight repeating, right? So my error is at most 0.09. Well, I already kind of got 0.91, right? And then what we get, 0.89? And what is that, 0.02? So certainly this is bigger than my error.
So you were within reason.
Exactly. But I'm not going to ask you to do that. You'll see if you're doing the homework, you'll see as you do more and more rectangles, you get the better and better estimate of the area, of course. And then we want to go GeoGebra. And I'm searching for Simpson's rule. If I leave the apostrophe out, I get one I like right away. Doesn't matter which one I just want to be able to type in the function, right? Didn't I have this problem last time? I couldn't, oh, there we go. I got it in the box. X e raised to the negative x. I'm putting the parenthesis in because I'm not sure, you know, how accurate this program is, but we'll see. I want n is 4 rectangles, right? And then I have to adjust my start. So I wanted to start at 0. And end at 4. Why is it not running for me? It doesn't like my function, or I don't know. Say again? Yeah. Does not like my function. I was supposed to do this for you already. Sorry about that. Let me do this. X divided by e to the x. There we go. From 1 to 4. 4 rectangles. And where is my area? Damn it. I'll find a better one. You play around with it. Find one Find one that you like, because you're going to be allowed to use it on the test. The thing is, I've got to be able to put in my function. There we go. Show Simpsons. Not giving me anything. Please find one that is good and share it with me. Okay? And of course, if I put the apostrophe in, it's going to give me a whole Simpsons rule. So there's a whole bunch of other ones to look for. Okay, good. A little extra work for you to do. All right.